Basic definition and terminologies has three types, which is linear differential equation, linear combination of solution, and linear superposition principle. Linear differential equation, take a look at white box there. The first white box there is what we call as a general form, and if equation fx equal to 0, it is a linear homogeneous equation, and if it's not equal to 0, it is linear non-homogeneous equation. And linear combination of solution, the general solution of the differential equation is y equal ay1 plus by2. If y1 and y2 are linearly independent and each of them are the solution for differential equation, the equation that highlighted up of it, and linear superposition principle, that is general equation. Okay, now I will talk about solution to homogeneous equation. So first of all, we have to consider the second order homogeneous equation, that in one Roman equation is linear homogeneous second order differential equation, and then we have to use second equation and assuming y equal to e power of mt dy dx equal to m, and then we put two Roman into one Roman and becomes a m square plus b m plus c equal to 0. And then we have to find root of equation, because the equation in green, the first green is what we call quadratic equation. Also we can find the two answers, m1 and m2, and if b square minus 4ac is larger than 0, roots are real and distinct, which means m1 not equal to m2. So the general equation is y equal a exponent power of m1x plus b exponent power of m2x. And if b2 minus 4ac equal to 0, the roots are real and equal, which means m1 equal to m2. So the general equation is y equal bracket a plus bx close bracket exponent power of mx. And lastly, if b square minus 4ac if less than 0, roots are complex and conjugate numbers, which is a plus alpha plus minus beta imaginary. So general equation is y equal exponent power of ax bracket a cos beta x plus b sin beta x.
Okay, I will explain about mechanic vibration. Maybe in the past year you already learned about vibration. Now I will explain the mechanic vibration. That means we have to solve the calculation when the vibration and the general equation for mechanic vibration is my plus by plus qy equal to ft. Okay, I will explain about type of vibration. The first type is undamped free vibration, mean non-damping or no vibration involved. My y plus ky equal to 0. Then we have the homogeneous equation. The second type, damped free vibration, mean not vibration involved my plus by plus ky equal to 0. Then we have a homogeneous equation. And the three type undamp force vibration mean not damping involves my plus ky equal to ft. That then we have a non-homogeneous equation, and the fourth type is damped force vibration. That means all element involved my plus by plus ky equal to ft. Then we have a non-homogeneous equation. Okay, now I will explain about method of undetermined coefficient. They have four cases for this topic. The first case is a polynomial of degrees n, and the second case is fx is in the form of CE, where C and M are constant, and the third case is a sine or cosine function, and the last case is sum of the above case.
Hi, my name is Isma Batrisha. To summarize topic 2.3.2 about solving higher order linear ordinary differential equations, the first one is third order. In the third order, there are four cases. The first one, roots are real and distinct, which means the three roots are not equal to each other. Second one, roots are real and equal, which means the three roots have the same value. The third one, combination of real, distinct, and equal roots, which means m1 equal to m2 but not equal to m3, or vice versa. The fourth one, the last one, combination of distinct and complex roots, m1 bracket m2 m3 equals to alpha plus minus beta I. Steps of solutions are same as in the second order. In the final solutions, yx is equals to yhx plus ypx. So next, in the fourth order, there are five cases. The first one, roots are real and distinct, which means the four roots are not equal or not have the same value. The second one, roots are real and equal, which means the four roots have the same value. The third one, combination of real, distinct, and equal roots. m1 equal to m2, m3 is not equals to m4, or vice versa. The fourth one, combination of real, equal, and complex roots. m1 equals to m2, bracket m3 m4 equals to alpha plus minus beta I. The last one, the fifth cases, combination of real, distinct, and complex. m1 is not equals to m2, bracket m3 m4 equals to alpha plus minus beta I. The steps of solution are same as in the third order. The final solution is same also, yx equals to yhx plus ypx. To summarize 2.3.3, method of variation of parameters. It can be used to solve a differential equation when the coefficient of differential equation are in the function of x. It also can solve non-homogeneous second-order ordinary differential equations with constant coefficient. The advantage of using this method, it can handle all types of functions such as tangent x, secant x, ln x, and many more. As you can see, these are the 5 steps to solve the equation by using the method of variation of parameters.
Next, the application of second-order differential equation is Rlc circuit. Notation of RLC circuits have 6, which is V for voltage, I for current, R for resistance, L for inductor, C for capacitance, and Q for the charge. The equation of RLC is L di over dt plus Ri plus Q over C equal to ET. Next, initial condition must be used in order to answer RLC circuit question, which is QO equal to Q initial, IO equal to I initial. Q is charge and I is current. We also can use I equal to dQ over dt. There are two methods to solve RLC circuit problem. First is solve in Q terms, second is solve in I terms. Q is in terms of charge and I is in terms of current. First method to solve RLC circuit question is solve in Q terms. In order to use these terms or method, first we must change the dependent variable from current to charge. Next, solve the non-homogeneous equation and then use initial condition to determine the equation using the initial charge. Or you also can use current equal to dQ over dt. And lastly, determine the current. Next, second method to solve RLC circuit question is using solve in I terms. First of all, we must differentiate the equation. The equation must be in simplified form. And then, we must find IT. Next, we must determine the constant, which is A and B. And then, form IT and use new condition to determine constants. And lastly, determine the equation for charge.
Assalamualaikum and hi, my name is Radin Hazka Huda binti Radin Bahrain, and I will tell you more about examples in RLC circuit. So the first question is, at t equal to 0, a current of 2 ampere flows in an RLC circuit with resistance equal to 40 ohms, inductance L equal to 0.2 Henry, capacitance C equal to 10 to the power of negative 5 farads. Find the current flowing in the circuit at t more than 0 if the initial charge on the capacitor is 1 coulomb. Assume ET equal to 0 for t more than 0. Okay, so we will use the L di over dt plus Ri plus Q over C equal to ET. We substitute all the information that is given, so we get 1 over 5 di over dt plus 40I plus 10,000 Q equal to 0. From that, we use the calculator to find the value of R. And then we get plus minus 100 plus 200I. So the R value will be the QH. And then the general solution for the equation is Q equal to e to the power of negative 100t bracket A cos 200t plus B sin 200t. By differentiating and collecting the like terms, we get Q equal to negative e to the power of 100t and 100A minus 200B cos 200t plus 100B plus 200A sin 200t. And then we will find the value of A and B from substituting the Q bracket 0 equal to 1. It meaning when t is 0, Q equal to 1. And then we obtain A equal to 1 and B equal to 51 over 100. So we get Q equal to e to the power of negative 100t cos 200t plus 51 over 100 sin 200t. We continue to find the Q prime and Q double prime. And then we substitute it back into the first equation. So we obtain I equal to e to the power of negative 100t 2 cos 200t minus 251 sin 200t. The second question is Determine IT if ET equal to 100 volts, R equal to 20 ohms, L equal to 1 Henry, and C equal to 1 over 100 farads. So we use the equation L di over dt plus Ri plus Q over C equal to ET. We know that I equal to dq over dt. So we substitute dq over dt into the equation. We get d square q over dt square plus 20 dq over dt plus 100q equal to 100. So the qh equal to m square plus 20m plus 100 equal to 0. We find the roots. M1 and M2 is the same, negative 10. So the general solution for QH is A plus BT e to the power of negative 10t. For the QP is the 100. We can continue finding the derivative of QP. So QP prime and QP double prime equal to 0. We substitute and then we can get the C naught. C naught equal to 1. We substitute it back into the overall equation QT. Then we get A plus BT e to the power of negative 10t plus 1. Since we know I equal to dq over dt, so we have to differentiate the QT equation to get the IT. So we differentiate and then we get negative 10A plus BT bracket e to the power of negative 10t minus 10 BT e to the power negative 10t. By using the initial problem value, we know that when t equal to 0, I equal to 0. So we substitute it into the IT equation and then we get B equal to 10. From the QT equation, we can substitute t equal to 0 and q equal to 0. And obtain that A equal to negative 1. So after substituting, we know that the particular solution for IT equal to 100 t e to the power of negative 10t.
The governing equation is L di over dt plus Ri plus Q over C equals to ET. This equation. And from the equation, we can get L equals to 10, R equals to 20, ET equals to 100, C equals to 6260 power of negative 1. We can solve this equation using Q terms. Replace all the given information into this equation. So we can get 10 di over dt plus 20i plus 6260q equals to 100. First step is change dependent variables to q. Since I equals to dq dt, therefore equation 1 will become this equation, 10 d square q over dt square plus 20 dq over dt plus 6260q equals to 100. And we simplify it and we get this equation and we name it as equation 2. And this one is equation 1. Then solve non-homogeneous equation. By using this equation, we can get m square plus 2m plus 626 equals to 0. And use your calculator and we can get m equals to negative 1 plus minus 25i. So QH will become e power of negative t, open bracket, a cos 25t plus b sin 25t, close bracket. And then we have to find QP. Ft equals to 10, QP equals to C naught. And we find C naught. And we know d square q over dt square equals to dq dt equals to 0. So we replace this to 0 using this equation. And we can get C naught equals to 10 over 626. And then after that, use initial condition to determine the constant A and B. We know Q0 equals to 10 from this. So 0 equals to A plus 10 over 626, and we can get A here. So QT will become e power of negative t, open bracket, negative 10 over 626 cos 25t plus b sine 25t, close bracket, plus 10 over 626. And we have to differentiate it because we don't have the equation it to apply the condition. So we can use product rule. U equals to e power of negative t, and we differentiate it, will become negative e power of negative t. V is negative 10 over 626 cos 25t plus b sine 25t, and we differentiate it, and it will become 250 over 626 sine 25t plus 25b cos 25t. And we can replace it using uv prime plus vu prime, and we can get this equation. And then simplify it, and we get this. This one we can simplify it, but I don't want to simplify it. Okay, next, we know I0 equals to 0 from this equation. Okay, now we replace all t terms into 0, and we can get what is b, this. B equals to negative 1 over 1565. Then we can get what is QT. This QT, this one is A. Sorry, this one is A. And this one is B. So we can get QT. So now we have to find I. I equals to, we use this equation, this one. Use this equation and replace B with negative 1 over 1565, and we can get the answer, which is 2 over 5 e power of negative t sine 25t. Thank you.